Hello everyone! Welcome back to another video lesson with me, Teacher Joy. In today's tutorial, we will have physical science. Let's discuss about Big Bang Nucleosynthesis, the beginning of elements, the formation of the light elements in the Big Bang theory. After this tutorial lesson, you should be able to give evidence for and explain the formation of the light elements in the Big Bang theory. So, what elements were produced during the Big Bang expansion? Big Bang theory is a cosmological model stating that the universe started its expansion about 13.8 billion years ago. An expansion from a singularity. Pieces of evidence supporting this theory are occurrence of redshift, background radiation, and abundance of light elements. Evidence number 1, the occurrence of redshift. In 1910, two scientists, Vestus Leeper and Carl Wilhelm Wirtz, measured the wavelengths of light from spiral nebulae, which are interstellar clouds of dust and ionized gases. They discovered that the light from the nebulae increased in wavelength. They explained their discovery as a Doppler shift. Doppler shift or Doppler effect explains that when an object gets closer to us, the light waves are compressed into shorter wavelengths. We call this as blue shifted. Because the blue light has the shortest wavelength in the visible region. On the other hand, when an object moves away from us, its light waves are stretched into longer wavelengths or red-shifted because red light has the longest wavelength in the visible region. Sleeper and Wirtz then explained that the redshift or increase in the wavelength was due to the increase in the distance between the Earth and the nebulae. They concluded that the redshift occurred due to the expansion of space. In 1929, Edwin Hubble used the redshift of light from galaxies to calculate the velocities and distances of these galaxies from the Earth. He discovered that they were moving away from the Earth and from each other. His calculations supported the theory that the universe is expanding. Evidence number 2, CMBR, Cosmic Microwave Background Radiation. In 1965, Robert Wilson and Arno Penzias discovered a low, steady hum from their Holmdel-Horn antenna, or an antenna built to support the NASA's Project Echo. They concluded that the noise is cosmic microwave background radiation, or CMBR. These are remains of energy created after the Big Bang expansion. Evidence number 3, abundance of light elements. The abundance of light elements observed supports the Big Bang theory. The theory predicts that the universe is composed of 73% hydrogen and 25% helium by mass. The prediction correlated to the measured abundance of primordial material in unprocessed gas in some parts of the universe with no stars. Now, let's talk about Big Bang Nucleosynthesis, the formation of light elements. Big Bang nucleosynthesis is the process of producing the light elements in the Big Bang expansion. In the beginning, the universe was very hot that matter was fully ionized and dissociated. Few seconds after the start of the Big Bang, the universe was filled with protons, neutrons, electrons, neutrinos, and positrons. Protons are also known as protium or hydrogen 1, the first element that was formed during the Big Bang nucleosynthesis. After the first 3 minutes, the universe cooled down to a point where atomic nuclei can form. Therefore, protons and neutrons combined to form atomic nuclei such as deuterium. Deuterium is also known as hydrogen 2. In the process, a photon is released. However, the temperature of the universe was still much greater than the binding energy of deuterium. Binding energy is the energy required to break down a nucleus into its components. Therefore, deuterium easily decayed upon formation back to protium or hydrogen 1. When the temperature cooled down below 10 raised to 10 Kelvin, deuterium nuclei combined with other nuclei to form heavier ones. Helium-3 was formed from the fusion of 2 deuterium nuclei and a release of a neutron. Tritium or hydrogen-3 was produced from the fusion of 2 deuterium nuclei and a release of a proton. Helium-4 was produced from the fusion of deuterium and tritium. Helium-4 was also synthesized from deuterium and helium-3. For the first 3 minutes, a substantial amount of neutrons was converted into helium-4 nuclei before their decay. Helium-4 then combined to other nuclei to form heavier ones such as lithium-7 and beryllium-7. Lithium-7 was synthesized from helium-4 and tritium. Beryllium-7 was produced from helium-3 and helium-4. Among the light elements formed, deuterium, helium-3, helium-4, and lithium-7 were stable. Beryllium-7 was unstable, and therefore it decayed spontaneously to lithium-7. And that's the story of Big Bang nucleosynthesis. So let's have some review. Pieces of evidence that support the Big Bang theory are redshift, cosmic microwave background radiation, and abundance of light elements. Big Bang nucleosynthesis is the process of light element formation. The light elements that formed after the Big Bang were helium, deuterium, and trace amounts of lithium and beryllium. Deuterium, helium-3, helium-4, and lithium-7 were stable. On the other hand, beryllium-7 was unstable and decayed spontaneously to lithium-7. Now, let's find out if you can give the evidence for and explain the formation of the light elements in the Big Bang theory through this quiz. Question number 1. Which of the following refers to the process of producing the light elements such as helium? A. Supernova nucleosynthesis. B. Cosmic ray spallation. C. Big Bang nucleosynthesis. D. RP process. Yes, letter C. Big Bang nucleosynthesis is the process of producing the light elements during the Big Bang expansion. Question number 2. It is the aftermath of energy from Big Bang expansion. A. Gravitational wave. B. Cosmic microwave background radiation. C. Black body radiation. D. Magnetic field. That is correct. Cosmic microwave background radiation. Good job! Cosmic microwave background radiation, or CMBR, are the remains of energy created after the Big Bang expansion. Question number 3. Who is the scientist who used the redshift of light from galaxies to calculate their velocities and distances from Earth? A. Edwin Hubble. B. Vestus Leeper. C. Arno Penzias. D. Robert Wilson. Yes, it is Edwin Hubble. In 1929, Edwin Hubble used the redshift of light from galaxies to calculate their velocities and distances from the Earth. He then discovered that the galaxies were moving away from the Earth and from each other. Question number 4. According to the Big Bang theory, how much time was needed to produce the light elements hydrogen and helium? A. 13.8 billion years. B. 3 minutes. C. 7 million years. D. 5 hours. Exactly! Letter B. 3 minutes. Few seconds after the Big Bang, the universe was filled with protons, neutrons, electrons, neutrinos, and positrons. After the first 3 minutes, the universe cooled down to a point where atomic nuclei form. That is a great job! Question number 5. What happens when something redshifts? A. Its wavelength increases. B. Its energy increases. C. Its size increases. Or D. Its frequency increases. Nice answer! It's letter A. Red has the longest wavelength in the visible region, so the shift to longer wavelength is called redshift. Question number 6. What does increase in wavelength of light from a galaxy mean? Yes, it is. The galaxy is moving away from the Earth and the universe is expanding. As the light from the galaxies gets nearer to the Earth, the distance between the Earth and the galaxy increases, causing the wavelength of light to get longer. Question number 7. Which event during the Big Bang expansion led to the nucleosynthesis of helium-3 and hydrogen? Very good! That is a great job! The temperature of the universe cooled down below 10 raised to 10 Kelvin. Question number 8. What are the products of Big Bang nucleosynthesis from lowest to highest by mass? That is a good work! Hydrogen, deuterium, tritium, helium-3, helium-4, lithium-7, and beryllium-7. That is a great job! Good work, everyone! Congratulations! You were able to give the evidence for and explain the formation of the light elements in the Big Bang theory. The next question is, how are elements heavier than beryllium formed? This will be a separate lesson. In the next lesson tutorial, we will find out how are these elements heavier than beryllium formed. If you like this video lesson, don't forget to hit the like button and subscribe my YouTube channel so you can receive notifications of upcoming video lessons in science. Share this to your friends to help them understand lessons in physical science. See you in the next lesson tutorial. This is Teacher Joy signing off.